Hello everybody, my name is Babu Bassa. In today's video, I will demonstrate to you how to download, install and use the Dilution app on an Android device. Basically what we need is an Android device like a cell phone with Wi-Fi connectivity. We must be able to access the internet from the device. So on the Android device, you have to first tap on the Google icon, this one, and then again the second Google icon. Now in the address bar, github.com, github.com / BBASSA9824, that is my account with the GitHub, and then / again, then the Dilutions in camel case, that is T capital HE and then D capital ILUTIONS, then / releases. Once you type this, please check that all the spellings are correct. github.com BBASSA9824, the Dilutions and releases. Then tap on the search icon. This is the magnifying glass. That will take us to my account page on GitHub. This is the one. So this is the site where you see the GitHub my account, and you scroll it and tap on assets, then on the Dilution app APK, that is the Android package. Once you tap on that, this is I already have, so it says download again, otherwise it is just download. Tap on download and then open. So and then install. You can see this mark installed. Now it is installed, and then open. This is the opening screen of the app, that is the user interface, an icon to the apps menu on your phone. So scroll it and find it, find where it is. I will show you where it is. See, this is the one, Dilution app. If you tap on it, you can open it again. So now I will show you how to use the app itself. First, dilute. I have covered many concentration expressions. Give some name to the compound and then say stock concentration 100 mg per ml. This is weight based expression of the concentrations. So now final concentration, if you say, for example, you can request up to 6 final concentrations. For example, if you are testing a compound for time and dose, you can do that. 2, 3, 4, 5 and 6. So you will enter the values and enter the units only one time at the end. So tap on units and say this time mg per ml. Then for example, this volume in the cell culture dish or assay buffer, that is the final volume, is, for example, if you are using 6-well cluster dishes for cell culture, I would say 2 ml, enter. So it has given the instructions for the volumes that you have to draw to accomplish this final concentrations. Here we do not need serial dilutions. The concentrations are not really low and the volumes are measurable, like 120, 180 and 60, 40, 20 microliters. Next I will show you stock concentration, for example, is 100 mg per ml, but we are requesting 1, 2, 3 To save time here, I will say take only 3 concentrations, and this time I will ask for microgram per ml. And volume again 2 ml. So this time we need serial dilutions because with the final concentrations are low. So we have to specify a volume that we intend to add to the final volume, for example cell culture dish or the assay buffer. Normally the test compounds are dissolved in organic solvents like DMSO. So we keep the pipetted volume, pipetted to the cell cultures, etc. very low. I will say here 5 microliters. Units and microliters. So this has generated serial dilution instructions. These are serial dilution instructions. It uses a different equation for this. Once we enter the intended pipetted volume, it will generate the serial dilutions. And we can use molar units also. It is same 100 millimolar, for example, millimolar. And final concentrations we request, I'm sorry, it has to be comma, separate the values with commas. And say 3, I will ask for say nanomolar, volume again 2 ml, and enter. Again it will ask you for, I will say 10 microliter, the pipetted volume. And then these are the serial dilution instructions. You can verify them whatever way. And then I will also show you one more way. For example, if you have say weight based stock solution mg per ml, 10 mg per ml or 100 mg per ml, you can put whatever. You can request the final concentrations in molar units. For example 2, 4, say nanomolar. Then final volume 2 ml. It can be any volume, but here I am giving you examples. Then enter. So since weight based units are for the stock concentration and we are asking for molar units for the final concentration, we need to enter the molecular weight. I will say 200. Enter. And then again the concentrations are ultra low and the procedure requires serial dilution. So specify a pipetted volume. I will say 5 microliters or 10 microliters, 20 microliters, whatever, depending on the solvent in which you dissolved the test compound. You can go all the way up to the final volume. Anyways, the compound, okay. Once we did that, it generated the instructions again. Then I will show you the other concentration types that we frequently use in a lab, and we use very frequently the fold dilutions, times dilution or fold dilutions. Especially, for example, if you are titrating serum, so serum, we will take serum concentration as 1. So stock concentration, it can be even a biological bacterial sample, 1. And units, you need to select anything, anything, and then final concentrations. For example, these are fold dilutions, 1000 fold, 2000 fold, etc. So units for this you have to select as times, that is fold. And say you are titrating serum and your assay volume is 1 ml. Enter. Again, since the dilutions are very low, basically the concentration is ultra low, it needs serial dilutions and specify some volume, say 10 microliters. And these are the serial dilution instructions for this particular query. Then I will show you also one more concentration type, weight by volume. Weight by volume concentration is called percent, And in chemistry, percent solutions are defined as uh, grams per 100 ml, grams per deciliter. Say you have a stock concentration of 1% units and weight by volume percent. Choose that, and suppose you want to ask the final concentration in molar units. So say 2 and 4 millimolar, say millimolar, whatever, each time I want to change. Then your final volume might be say 1 ml. Enter. Again we need molecular weight because final concentrations we requested are in molar units. So I will put the molecular weight 2 to 2 whatever, and then these are the concentrations we requested are not ultra low. We requested millimolars. It did not ask for the pipetted volume. Basically it has given the instructions. I will go to the next example, that is of diluting the solvent. Dilute and go to, say for example we have methanol at say 80% concentration. You have to select this time volume by volume percent, and then final concentration you want maybe 20% units, and volume by volume percent again, and then say 100 ml. We use methanol in bulk volumes, so let me say 100 milliliters. Enter. This is the volumes are here in microliters, otherwise it is 25 ml plus 25 ml methanol stock plus 75 ml water. I might later change this to milliliters, convert them to the milliliters. Just I left them like that to cover a wide range of volumes. Please explore, for example, all the units that are available, like it has parts per million, normality, cells per ml, cpm per 10 microliters, etc. Most of them have only label value, but the calculations will be accurate. You can use that. Once you are done with this, the next one is archives. The next button says archives. When you press archives, you will get all the queries that we have done today. They are saved in a small database on the phone. We do not know the capacity of the database, but they are saved. The only way you can transfer them to your personal computer is through email. If you say email, and printing also can be accomplished by transferring this data by emailing itself, like email. And I have my email address here because the phone already knows my email address. Otherwise I will send it to the same email address, gmail.com, and then send. So all the data that we queried today, all the output of our queries today are saved and they are sent to my email address. From there you can print. And then exit would exit us from this app.